Dear students, under the lecture series on complex analysis, previously we learnt about Cauchy-Riemann equations. Now here we are going to verify the Cauchy-Riemann equations for the given functions. What is Cauchy-Riemann equation? That is, if a function satisfies ux is equal to vy and uy is equal to minus vx, then we say that the given function satisfies the Cauchy-Riemann equations. So these two we have to verify now for the given function. Here the given function is f of z equal to z cube. We know that the complex variable z is equal to x plus iy. Now here we have f of z to be equal to z cube, which is equal to x plus iy the whole cube. Now we shall expand this by using the formula a plus b the whole cube, which is equal to a cube plus 3a square b plus 3ab square plus b cube. So using this, when we expand, here we get this to be equal to x cube plus 3x square multiplied with iy plus 3x multiplied with iy square plus iy the whole cube. Now this is equal to x cube plus, I am considering the imaginary I value, and 3x square I am writing x square y I am writing together, and here it will be I square, that is 3xy square multiplied with I square, and then plus I cube y cube. Now what is the value of I square? I square is equal to -1. And what about I cube? It can be written as I square multiplied with I, which is equal to -1 multiplied with I, that's equal to minus I. So we shall write that here. So that's equal to x cube plus I multiplied with 3x square y, and we have I square here. The value of I square is -1, so it is minus 3xy square, and I cube is minus I, so minus I y cube. Now we shall separate the imaginary part and the real part. So here the real part is x cube minus 3xy square, which are independent of I. So x cube minus 3xy square plus the imaginary part is 3x square y minus y cube. Now we have written the function f of z in the form u plus iv, where the function u of x is equal to, so the function u of x comma y is equal to the real part, which is x cube minus 3x y square, and the function v of x comma y is the imaginary part, that is 3x square y minus y cube. In short, we can say this as u and this as v. So now, in order to prove the CR equations, we have to partially differentiate u with respect to x first, which is represented as ux. So what is the partial differentiation of this? That is, y has to be treated as constant and differentiated. The differentiation of x cube is 3x square minus 3x we have here. So what is the differentiation of x? It is 1. And y square remains constant, and so it comes as it is. And so therefore this is ux is equal to 3x square minus 3y square. Next we have to find uy. So which is equal to differentiating u partially with respect to y. Now x will be treated as constant, because of which this will become 0 on differentiation. And minus 3x remains constant, and the differentiation of y square is 2y. And so we get minus 3 2 times is 6xy. So therefore we have obtained ux to be this and uy to be this. In a similar manner, we shall find vx and vy. So Vx gives us the partial differentiation of V with respect to x. So now y will be treated as constant here. So 3x square has to be differentiated, that is 3 will come as it is. Differentiation of x square is 2x, and y, since it is a constant, it remains as it is. Whereas here it becomes 0 because there is no x term with it. So we get this, which is equal to 3 2 times is 6xy. So this is Vx. Now next we will find Vy, which is equal to differentiation of V partially with respect to y. So x will be treated as constant. So 3x square comes as it is, and the differentiation of y is 1 over here, minus the differentiation of y cube is 3y square. And so therefore we obtain 3x square minus 3y square. So this is Vy. Now we shall check whether it satisfies the CR equations, that is Cauchy-Riemann equations. The first Cauchy-Riemann equation is Ux is equal to Vy. So let us check here. What is Ux? It is here 3x square minus 3y square. Vy is 3x square minus 3y square, which means Ux is equal to Vy. So first equation is done. What about the second one? We have to check whether Uy is equal to minus Vx. So now if you check here, Uy is minus 6xy, and what is Vx? It is 6xy. So Uy is equal to minus Vx. So therefore Uy is equal to minus Vx. So the second equation is also satisfied, and hence we have verified the Cauchy-Riemann equation for the given function f of z equal to z cube, which has satisfied those two equations. So here we have the second question, f of z equal to e power z, which is equal to e power x plus iy, as z is equal to x plus iy. Let us check whether this function satisfies the Cauchy-Riemann equations. For that we shall first split up this and write. So e power x multiplied with e power iy. Now further this will be equal to e power x, and by Euler's formula we know that e power iy can be written as cos y plus I sin y. Now separating this into real part and imaginary part, we get the values of u and v. So where u is equal to e to the power x cos y, which is the real part, and then the imaginary part is v is equal to e to the power x into sin y. So e power x sin y is the imaginary part. So now we shall differentiate this partially with respect to x. So ux will be equal to cos y will be treated as constant, and the differentiation of e power x is e power x itself. So e power x cos y is what we obtain. Next we shall differentiate with respect to y. So uy will be equal to, now e power x will be treated as constant, and the differentiation of cos y is negative sin y. So multiplying these two, we get uy to be equal to minus e power x sin y. In a similar way, we shall differentiate v with respect to x, which is equal to e power x, differentiation is e power x, and sin y will be treated as constant. And differentiation of v with respect to y. Now e power x will remain constant, and the differentiation of sin y is cos y. So now if we see here, ux, which is e power x cos y, is equal to vy, which is e power x cos y. So we obtain ux to be equal to vy. In a similar way, we see that uy is equal to negative e power x sin y, and vx is equal to e power x sin y, implying that uy is equal to minus vx. So uy is equal to minus vx. Hence the given function has satisfied the Cauchy-Riemann equations. Here we have the next question, f of z equal to sin z. So now this is equal to sin x plus iy. Since z is equal to x plus iy, f of z is equal to sin x plus iy. Now the sin x plus iy has to be expanded by using sin a plus b formula. So the formula for sin a plus b is equal to sine A cos B plus cos A sine B. So we are going to apply this formula over here, where A will be x, and B will be IY. So therefore this will be equal to, that is f of z will be equal to sine A, so sine x, then cos B, so cos IY, plus cos A, so cos x, sine B, so sine IY. Now by the concept of hyperbolic functions, we know that cos IY will be equal to cos HY. In a similar manner, sine IY will be equal to I sine HY. These are from the concepts of hyperbolic functions. So having this, we shall now substitute cos IY to be equal to cos HY and sine IY to be equal to I sine HY. So this will be equal to sine x multiplied with cos IY is cos HY, plus cos x will come as it is. Sine IY is I sine HY. So that I am writing here, and sine HY. So this is our f of z now. So this is the real part and this is the imaginary part, and so the function u is equal to the real part, that is sine x cos HY, and this is the imaginary part, and so v is equal to cos x sine HY. Now from this we shall obtain ux. So what is ux? It is the partial differentiation of u with respect to x. So y will be treated as constant, and so this will remain as it is. Now we have to differentiate only sin x. What is the differentiation of sin x? It is cos x. So this comes as it is. So cos HY. Next we have to differentiate u with respect to y. So sin x will be now treated as constant, so it comes as it is. And what is the differentiation of cos HY? It is sin HY. So remember, the differentiation of the hyperbolic function cos HY is sin HY. Do not confuse this with the differentiation of cos y, which is not a hyperbolic function. So in hyperbolic functions, differentiation of cos HY is sin HY, and the differentiation of sin HY is cos HY, irrespective of the trigonometric function, where the differentiation of sin x, sin y will be cos y, whereas the differentiation of cos y will be minus sin y. There we will be having a negative sign, whereas in the differentiation of the hyperbolic function, it comes as it is, without the negative sign. Now here we have v. So differentiation of v with respect to x is equal to sin h will be treated as constant now. So differentiation of cos x is what? Minus sin x multiplied with sin hy, and so therefore this is minus sin x sin hy is what we obtain. Now differentiation of v with respect to y. So x will be treated as constant, so cos x comes as it is, and as I told you, the differentiation of sin hy is cos hy. We shall check whether these satisfy the CR equations. So now if you see, what is ux? It is cos x cos hy, and vy is cos x cos hy, from which we obtain ux is equal to vy. So first condition is satisfied. Now next here we have uy to be sin x sin hy, whereas and here vx to be minus sin x sin hy, which obviously implies that uy is equal to minus vx. So therefore the second condition is also satisfied. Hence the CR equations are satisfied for the function f of z equal to sin z. So now next we have the fourth question on this topic, where it is given in terms of x and y. The function f of z is given in terms of x and y. So directly we can take and write the real part. So the real part is e power x cos y. So u is equal to e power negative x cos y. And what about the imaginary part? It is e power minus x multiplied with minus sine y. So the imaginary part is v is equal to e power minus x, and we have minus, so minus I'll put here, and then sine y. So next is finding ux, differentiating u partially with respect to x. Y will be constant, and so differentiation of e power minus x is minus e power minus x cos y comes as it is. Next, differentiation of u with respect to y, which is equal to, now e power negative x will be treated as constant, and what is the differentiation of cos y? It is minus sine y. So this minus I'll put here, and we have sine y. In a similar way, vx is partial differentiation of v with respect to x. So here we have a negative sign already, and the differentiation of e power minus x is minus e power minus x. So this minus and the minus that we get after differentiation gets multiplied and it becomes plus, and so we have e power minus x, and sine y comes as it is since it will be treated as constant. Differentiation of v with respect to y will be equal to minus e power minus x comes as it is, and the differentiation of sine y is cos y. Now we shall check whether they satisfy the CR equations. We see that ux is equal to minus e power minus x cos y, and vy is also the same. Therefore ux is equal to vy. The first equation is satisfied. Next we shall check uy, which is minus e power minus x sin y, and vx is e power minus x sin y. So e power minus x sin y. So we have a negative here. Therefore uy is equal to minus, what is this? Vx. So we see that the second condition is also satisfied. Therefore the given function satisfies the CR equations. So here we have the last problem of this lecture. So now here u is equal to cos x cos hy, and v is equal to minus sin x, the imaginary part, sin hy. We shall differentiate u with respect to x first. Now y will be treated as constant. Differentiation of cos x is minus sin x. Since this will be treated as constant, it will come as it is. Next we will differentiate with respect to y. So uy is equal to cos x will come as it is. And what is the differentiation of cos hy? It is sin hy. I have already told you that. Next we have vx, which is the differentiation of v partially with respect to x. Y will be treated as constant. So differentiation of sin x is cos x. This minus will come as it is, cos x, and sin hx will come as it is, since it will be treated as constant. Next vy, partially differentiating v with respect to y. So minus sin x comes as it is, and the differentiation of sin hy is cos hy. Now we shall check whether they satisfy the CR equations. We see that ux is equal to minus sin x cos hy, and vy is equal to minus sin x cos hy, which implies ux is equal to vy. Therefore the first condition is satisfied. Next uy is what? Cos x sin hy, and vx is minus cos x sin hy. So we observe that uy is equal to minus vx. Therefore the second equation is also satisfied. Hence the given function satisfies the CR equations. So I hope you would have understood the concepts of CR equations. So kindly follow the upcoming video lectures for more problems under nowhere differentiable. Thank you.